There are very few construction projects in the modern world that genuinely feel like they belong in the future. Most cities evolve slowly. They expand outward, layer by layer, shaped by geography, politics, economics, and human habit. Even the tallest skyscrapers or most advanced transit systems are still bound by the same fundamental logic. Cities grow organically over time, but every once in a while, a proposal emerges that doesn't follow that logic at all. A project so ambitious, so radically different in its design, that it doesn't just aim to improve cities, it aims to completely reinvent them. This is one of those projects. In the deserts of northwestern Saudi Arabia, planners have proposed a city called The Line, a 170-kilometer-long, mirror-clad structure designed to contain millions of people in a perfectly linear urban environment. No traditional streets, no cars, no urban sprawl, everything compressed into a narrow vertical corridor stretching across the desert landscape. At least that is the vision. On paper, it sounds almost impossibly clean. A city where every essential service is within walking distance, where transportation is reduced to a high-speed underground system that can move people end to end in minutes, where emissions are eliminated entirely and urban life is redefined around efficiency and density rather than expansion. But as with all mega-projects of this scale, the reality becomes far more complicated the moment you start asking how. To understand The Line, you first have to understand the broader project it belongs to, NEOM. NEOM is not just a city. It is a planned region of entirely new developments, backed by an investment exceeding $500 billion. Its goal is to create multiple futuristic urban zones powered by renewable energy, advanced automation, and experimental architecture. The Line is its most ambitious centerpiece. It is designed as two parallel mirrored skyscrapers, each rising approximately 500 meters into the sky, running continuously for 170 kilometers across desert terrain. Between these structures lies a tightly controlled internal environment where all human activity is meant to take place. In theory, this creates a city that is incredibly efficient. With everything stacked vertically, land use is minimized. Infrastructure is centralized. Movement is optimized. Urban sprawl, one of the biggest challenges in modern cities, is eliminated entirely. Instead of expanding outward like traditional cities, the Line compresses everything inward. But compression at this scale introduces problems that have never been solved before in engineering history. A continuous megastructure of this length is unlike anything ever attempted. Even the tallest skyscrapers in the world are isolated vertical systems designed to withstand wind, seismic activity, and material stress in a single location. The Line, however, must maintain structural integrity across a horizontal span of 170 kilometers. That means dealing with variations in soil composition, temperature extremes, wind loads, and potential seismic activity across an enormous geographic area. Materials expand and contract. Foundations shift slightly over time. Even microscopic movement, when multiplied across a structure of this scale, becomes a major engineering concern. Then there is the issue of thermal stress. In desert environments, temperatures can swing dramatically between day and night. Steel and concrete expand under heat and contract under cooler conditions. Over short distances, this is manageable. Over 170 kilometers, it becomes a continuous engineering challenge requiring precise control systems, flexible structural joints, and advanced material science far beyond conventional construction. This is not simply building a city. It is maintaining a single continuous structure under constantly changing environmental conditions. Beyond the structure itself, the internal systems of the Line introduce an entirely different level of complexity. The city is designed to operate without traditional roads or cars. Instead, transportation is handled through a high-speed automated system running beneath the surface. This system is intended to move residents from one end of the city to the other in approximately 20 minutes. In theory, this eliminates congestion entirely. No traffic lights, no intersections, no urban bottlenecks. But in practice, it requires a flawless integration of automation, logistics, and energy distribution across the entire length of the city. Every essential service, water, electricity, waste management, communications, must be synchronized through centralized systems that operate continuously without failure. Unlike traditional cities, where infrastructure can be localized and repaired in sections, the line functions as a single interconnected system. A failure in one part of the network could have cascading effects across multiple zones. This level of interdependence makes the system incredibly efficient, but also extremely fragile. Water supply is another critical challenge. The region where the line is being constructed has extremely limited natural freshwater resources. As a result, the project relies heavily on desalination, the process of converting seawater into usable freshwater. While desalination technology is well established, it is also energy-intensive and expensive. Scaling it to support millions of residents requires massive infrastructure and continuous energy input. In addition, transporting water across a 170-kilometer linear city introduces further complexity. Pressure systems, storage balancing, and distribution networks must all function flawlessly to ensure consistent supply. Energy production is similarly ambitious. The plan relies heavily on renewable sources such as solar and wind power, supported by advanced storage systems. But again, scale becomes the defining challenge. Generating enough clean energy to power not just homes, but transportation, desalination, climate control, and infrastructure systems for an entire city requires enormous land use and technological reliability. Even if all of this engineering works, there remains a more subtle question, one that is harder to measure, but just as important. What is it actually like to live in a city like this? Traditional cities evolve over centuries. They develop identity through randomness, history, and human behavior. Streets are shaped by time, neighborhoods form organically, people interact in unpredictable ways. The line, by contrast, is designed from the top down. Everything is pre-planned. Every space is optimized. Every system is engineered for efficiency. On one hand, this creates order and accessibility. Everything is close. Everything is connected. Everything is controlled. But on the other hand, it removes the organic unpredictability that defines most human environments. There are also psychological considerations. Living inside a continuous enclosed structure, even one with advanced environmental design, changes how people perceive space and movement. There is no traditional skyline, no natural sprawl, no variation in urban density across districts. Instead, there is a single continuous environment stretching endlessly in both directions. Urban designers have long studied how architecture influences behavior. The line pushes that relationship to an extreme that has never been tested at scale. Despite all of these challenges, it would be a mistake to dismiss the project entirely. Historically, many of the world's most advanced cities began as radical ideas that seemed unrealistic at first. Concepts like skyscrapers, underground metros, and fully automated transit systems were once considered impractical. The line, in its ambition, represents a continuation of that pattern, an attempt to rethink urban life in response to modern challenges like population growth, climate change, and resource efficiency. Even if the project is never completed in its original form, the technologies, systems, and design principles being developed could influence future cities around the world. Innovation in construction often emerges not from perfect execution, but from ambitious attempts that push engineering to its limits. So where does that leave the line? At this stage, it exists somewhere between vision and reality. Construction has begun, plans continue to evolve, and global attention remains fixed on whether such an unprecedented structure can actually be realized. It is a project defined not just by what it aims to build, but by the questions it raises about the future of cities themselves. Can urban life be compressed into a single linear structure? Can human behavior adapt to such a controlled environment? And perhaps most importantly, should it? Because in the end, the line is not just a construction project, it is an experiment in redefining how humans inhabit space. And like all experiments of this scale, its outcome will reveal far more than just engineering capability. It will reveal the limits of ambition itself. If you enjoyed this deep dive into one of the most ambitious construction projects in history, make sure to subscribe for more documentaries on the world's biggest engineering feats. And don't forget to check out the links in the description for more content like this.